Numericals on young double slit experiment. In a double slit experiment, the distance between the slits is 3 millimeter and the slits are 2 meter away from the screen. Two interference patterns can be seen on the screen, one due to light with wavelength 480 nanometer and the other due to light of wavelength 600 nanometer. What is the separation between the fifth order bright fringes of the two interference patterns? So here we are given small d equal to 3 millimeter, which will be equal to 3 into 10 power minus 3 meter, and capital D is given as 2 meter, and lambda 1 is given as 480 into 10 to the power minus 9 meter, lambda 2 equal to 600 into 10 to the power minus 9 meter. Fifth order bright fringe, we know nth order bright fringe is given by n capital D lambda divided by small d. So for the two wavelengths, we have to evaluate this. So x5 for 480 will be equal to n means 5 into d, that is 2 into 480 into 10 to the power minus 9 divided by 3 into 10 to the power minus 3, and for 600 nanometer wavelength, x5 dash will be 5 into 2 into 600 into 10 to the power minus 9 divided by 3 into 10 to the power minus 3. Now we have to find out the difference. Suppose it is delta x will be x5 dash minus x5. We put the values. So this will become 6000 into 10 to the power minus 9 divided by 3 into 10 power minus 3, minus this will become 4800 10 power minus 9 divided by 3 into 10 to the power minus 3. So on simplification, we will get 4 into 10 to the power minus 4 meter. Let's go to next question. A beam of light consisting of two wavelengths, 800 nanometers and 600 nanometer, is used to obtain the interference fringes in Young's double slit experiment. On the screen placed 1.4 meter away. If the two slits are separated by 0.28 nanometer, sorry, 0.28 millimeter, calculate the least distance from the central bright maximum where the bright fringes of the two wavelengths coincide. So let this let the two bright fringes will coincide at the least distance x from the central maximum. So what will be the condition? Condition is at lambda 1 d upon d must be equal to 1 more or 1 less. So n plus 1 times lambda 2 times d divided by small d. So this is the condition for coinciding the two interference fringes. So here d upon d will cancel out this d. So we will be left with n lambda 1 equal to n plus 1 lambda 2. We are given lambda 1 as 800, lambda 2 as 600, and we should not convert it in meter because they will get cancelled. So n times 800 must be equal to n plus 1 times 600. So if we simplify it, we will get n equal to 3. Now we have to find out the value of x. Here we have got the value of n. So x will be equal to 3 times this formula, bright fringe. Xn is n times d lambda upon small d. So 3 times for first one, 3 times d lambda 1 upon small d will be equal to 3 times d separation. It is 1.4 into lambda 1. So lambda 1, we are taking 800 nanometer. This time we have to convert it into meter. 10 to the power minus 9 divided by separation between the slits. It is 0.28 millimeter, 0.28 into 10 to the power minus 3. So this will come out to be 12 into 10 to the power minus 3 meter, which is equal to 12 millimeter. So this answer. Let's go to next question. In Young's double slit experiment, slits are separated by 0.5 millimeter. It means small d equal to 0.5 mm or 0.5 into 10 to the power minus 3 m. And the screen is placed 1 meter away. It means capital D equal to 1 meter. Fifth bright fringe is at distance of, we know xn equal to n d lambda upon small d. So here n equal to 5. So fifth bright fringe is at distance of 4.15 millimeter from second dark fringe. And the dark fringe will be given by xn minus 1. Here I will write the formula. So let's write it here. X5 will be equal to 5 times capital D lambda divided by small d. And the second dark fringe. So position of dark fringe is given by xn dash equal to 2n minus 1 times d lambda upon 2 lambda. So second dark fringe, it means x2 dash equal to 2 into 2 minus 1, that is 3 by 2 d lambda upon small d. Now, distance between these two is given as 4.5th bright fringe and second dark fringe. The separation is 4.13 millimeter. So we can say x5 minus x2 dash is 4.13 millimeter. So we put the values. So x5, that is 5 capital D lambda divided by small d minus 3 by 2 capital D lambda divided by small d equal to 4.13. It is in terms of millimeters, so this must be converted into meter minus 3. Now we can put the values to get lambda. So let's put the values. So we can write the expression for lambda either. So lambda, if we take common, then it will be 5d divided by small d minus 3d divided by 2d equals 4.13 into 10 to the power minus 3, or from here lambda times this is 2d, so this will become 10d minus 3d equal to 4.13 into 10 to the power minus 3. So this will 7d lambda times 7d divided by 2d equal 4.13 into 10 to the power minus 3, or lambda equal to 4.13 into 10 to the power minus 3 into this 2d, 2 into d, the separation 4.13. No, sorry, slits are separated by 0.5 millimeter. So it will be 0.5 into 10 to the power minus 3 divided by 7d. So 7 times d is distance of the screen, that is 1. Now, so if we simplify, so we will get 0.59 into 10 to the power minus 6 meter, which will be equal to 5900 angstrom. To convert this in angstrom, we multiply by 10 to the power 4 and divide by 10 to the power 4. So we will get this thing. Thank you for watching.